Right, evening students. Welcome to this sort of brief OOP crash course. So I've noticed that a few people have been struggling with the OOP concept. So today we're going to kind of try our very best to cover the general OOP concept, of course, and I'm going to do it through a actual practical example. We're going to try to build a RPG. Again, this is going to be a very basic RPG, but I am a massive fan of the Lord of the Rings, so we kind of go and I'm going to use that as an example going forward. So now we are going to be covering OOP predominantly, but I kind of want to show you guys how a procedural programming solution to an RPG, what it looks like, so that you can kind of compare and contrast the procedural way of doing things versus the OOP way of doing things. So we're going to kind of start out like procedurally writing something, and then we're going to pivot it to an object-oriented programming, so you guys can see how to kind of convert the two, if that makes sense. So basically, what we're going to do today, as well, is we're going to build a game, right? An RPG, so a very basic one. The general gist, to begin with, remember, start small. Always start small, then build big. So how to start small? I'm thinking we start by just creating a character, some sort of character. This will be our hero character, right? And that hero character gets to interact with another character. I'm gonna do a hat. It might be another character, or it might be an enemy character, or an orc character. So this interaction can be of any sort. Again, during your design phase, you will determine. We're gonna go do something simple, like again, given a weapon, we're gonna get this person to attack. So, so that's the general gist of it. So the things you kind of want to figure out is okay. If I'm gonna build a entity or an object or some sort of like structure, what do I need? So here, at the very least, for each character, we're going to need some sort of health pool as well. So like an HP, we're going to need some sort of strength of some sort, and maybe we'll see how it turns. We'll definitely need a name for each of them as well. We just can't call them hero and orc. So this is kind of what I need. So I need a couple of key features, and I need some actions at the very so again, later on you'll see this will translate into attributes and these the methods. For the time being, we're going to start very small. So hopefully that makes sense. To that effect, of course, I've created two files. We're going to start with this here file. I've put it in your repository, being the OP in a crash course right here in the extra, so outside of specialization and foundation. Again, I will push these up to the repository at hand so you can have them. Now, we're going to start with the RPG process. So what is it I need? What is it I need? But before anything, do not forget the if main equals name, if name of the file, we want our dunder guard, dunder main. So the very bare minimum, we're going to need a main function that's define main. Here we go, and pass for now. So at the very least, that is be a thing. Cool. So what as I said, what do I need? I need some sort of hero character. So what I want is a hero, some sort of hero, and I need his enemy, or in this case, an orc, maybe. I don't know. You can get creative, do better things. So I'd also need some sort of like attack. So I need some sort of attack process to, and of course, preferably I need a print here to say I don't know, like result. Maybe a print for welcome to the game. So these are all simple procedural programming stuff. So now, how you go about doing this, it depends on how you want to code it. But I have something in going. So I'm thinking I will then do something like this. I will create a function that says create character. And I can then feed it the attributes I want. So I know that my hero will have, for now I'll call it hero as well, maybe has a hit point of 100, strength of 50, maybe along those lines. So that's my hero character. So the same thing can be said for the orc character or the enemy character. So I call it orc. I'll call it orc 1 actually. I call it orc 1, and then orc's a little bit beefier. Let's say 140 health points and strength of, I don't know, 10. Doesn't matter. So, in the attack, so far we have it. So this is what I want. So notice, of course, I haven't created. So what I need to do is create this function. So create function. So the parameters, of course, this being name, this being, what would it be? It'd be health pool, it'd be health, and the other one will be, I don't know, strength. So far so good. So again, I have my main two characters. These are the characters that will be interacting with each other. I want to create some sort of system where I can get this character to attack this character or vice versa and have some sort of interaction and then result and print out things are going, such as, I don't know, hero attacks orc for 10 damage. And here are the results. Something along that line, like a basic text-based RPG, if you will. Now, so here's how I'm going to create each character. So the orc, now there could be any other characters, it could be rangers, it could be wizards, etc. I'm just going to use this fella to create a character. Because I'm dealing with procedural and because I want to keep this very, very easy and very straightforward, so I'm just going to create it here in the following manner. So make sure that I have not misspelled anything. How do I represent a character here in procedural programming is another question you might have. So how do I represent this person and his stats? So these, how do I couple these together in a meaningful manner that I can then use? Now, generally speaking, 9 out of 10, it'll be object, which in Python means a dictionary. So I'm going to use a dictionary here to represent each character and hold sort of their state. It's not called state here, we'll get to state later, but it's basically hold the container to hold the character itself. So it'd be something along the lines of this. It'd be like, the character will have a name, and I'll pass it the name there. The character will have a health pool of some sort. I'll pass the health pool there. And of course the character will have strength, EGT, which of course I'll pass strength there. And of course this all needs to be returned. So this will create, now if I just print out my hero character at this point, and if I execute this, here it is. So hopefully you guys can see it down here. I have printed my hero character, and my hero character went and got created, and the result is here. So this here container, if you will, this here dictionary or object now contains the essence of this hero, if you will. The actual it is the representation of my hero at this point. It represents this hero's name, which at the moment is blandly called the hero. How much health it has, as at the moment as 100, and of course this hero's current strength, which is 15. And if I've done the exact same thing with the second character, this is the second character, the orc as well. It has a name, it has a health pool, it has strength. So now I can use this. I can use this object being returned from this character to then do some sort of interaction. This actually does not necessarily need to be an attack. You can just build something that they go to a picnic together. It doesn't matter. I'm using attack because I like RPGs, but it's up to you. During the design phase, you may design whatever you want. Now the attack, again, I'm thinking design-wise, but I want my attack to be able to say attack from to. So have some sort of attacker and a defender, a source and a target. So the naming conventions is just arbitrary here. So I'm going to think I want to say something like the hero attacks the orc, or in this case, orc 1. So I want to pass these guys through. So now here I will go and create the hero function. So what would I name this? I would call it attacker. I think that makes sense. Defender. Again, you call it anything else along the line. So, and I would say print deal with attacking here. Just so I know things are coming through, I'm going to print attacker, and I'll print defender. I'm going to comment everything else out, so no more prints, do not distract me, no more hero, and I will keep the welcome. If I run this now, you see that after the welcome screen, the hero and the orc are created, they're passed into the attack, and here of course the attack is picking up the attacker and the defender, and here are they printed, so basically they're just being processed. So now I need to basically do a few things. It depends on how you implement it. What I need to do, of course, since I have both the attacker and the defender, I need to take, for example, the strength of my attacking person, do some sort of very basic math on it, and then basically take said off of the hit point of the person being attacked. So the attacker needs to attack, put in some damage, and that damage then needs to be taken off of the health pool of whoever is the defender. So that's the general list. Again, there's more than one way to write this. This is a completely arbitrary thing I just wrote 20 minutes ago, 10 minutes ago, as an example. We are going to be doing this object-oriented programming way later, and I'll tell you why that's very superior to this. But let's just, for sake of example, here's how it's done. I would say, look, cool. Let's calculate some damage here. So damage would be, I take the attacker and I take the attacker's strength. Again, remember, objects being passed here is strength. Did I mistype strength? Oh, it's replaced with... Oh, there's an N in there. Sorry, people. Quick typo. Quick typo. N, fine. Easy to fix. N. N, thank you. So, I take that, that's the damage. So, basically, then, all I need to do is then hook the defenders, pick up the health pool for the defender, and basically take that damage off of it. So, damage. I can do some sort of print here as well. I could do some sort of print here to kind of give a message out. Like, actually, for the sake of time. Again, you'll have access to these source codes as well, so you can copy and paste all you want. Something along this line. So, DMG. And I'll walk through this in a moment. So if I run this, let's just make sure it works. Alright, cool. Now, if we go over this now, what's happening here is that it's telling me the hero attacks Orc for 15 damage. Again, the hero's strength is 15. And the Orc has 125 hit points now. If we look at the code, our Orc had 140. Our hero has a strength of 15. When we do one attack round, of course, the damage gets calculated. Basically, this becomes the damage. Again, very basic logic. You can make this as sophisticated as you want. Put in some other variables or random interactions in there. Add in a random, etc. Doesn't really matter. We're keeping it simple for now. And voila, that HP here is being picked off. And then the rest of this is just nice logging. Because again, it's an RPG. It's a text-based RPG. You want to have text in there so that you kind of, in the interaction is visible. And it's pretty good activity to do nonetheless. So, and this is it. That's it. So we can, of course, likewise have an attack again, where this time the Orc, our friend Orc number 1, is attacking our hero. And of course, as we run it, you see now the Orc is taken off. Is now 120 hit points. Our hero is currently down to 190, given of course this math here. So hopefully this makes sense. So from here on, of course, this is completely procedural programming. From here, if you were coding this as well, you would have your functions, whatever you need, and then you would have your user start here. This would be a welcome screen. Maybe you prompt the user for something to pick a hero. You give them different hero classes. Everything's fine. You get a little result at the end to say something. Let me actually, begin the battle. So from here on, I leave it to you guys to decide what you want to do. And this is perfectly fine programming, now procedural wise. The issue arises here. It's not very scalable. I can't expand. Expanding this is a little bit problematic. Because if you look at, I've currently put in like 3 attributes here, 3 qualities. What if I need to create a wizard? If I need to create a wizard, so wizards have mana, for example. Let's just say if I need to create a wizard, a character, so that wizard has mana. So I have to put mana here. And then I have to add it here for each character. But then the problem is, of course, now I have to add mana to hero and Orc as well. And I'm going to be like, yeah, fine. I'm going to say 0 mana for you and 0 mana for you. The wizard eventually gets it. So now if I were then to create a wizard 1, I call him wizard, Wizzy, fine, and I give him, for example, 100 mana. That's pretty fine. I mean, it's doable. But I have to also calculate, of course, if the wizard is to then attack, what kind of attack does the wizard do? He probably throws a fireball, right? So now currently my attack function here is just a little bit too basic. I need to put some sort of magic in there, and then the logic here needs to expand. It gets very messy very quickly, and this is just a wizard. If you need to put in a ranger or different classes or an archer, so this just, as you see, as this scales, the complexity of this scales and it becomes very messy. So one of the issues, of course, of procedural programming, scaling. Another thing as well is, if you note here, my logic here is very separate. I have a character creation that's kind of on its own function. I have attack that kind of deals with the same thing, right? Attack kind of deals with the same character concept. They're kind of separate. So my logic is separate. My data is very separate. So there's no like structure, if you will, that things mesh together nicely. So in the case of encapsulation, if you remember, for object-oriented programming. So this is weak. We can do better. So hopefully this is an example. So what we're going to do is we're going to build sort of the same thing, but a lot more robust and more expanded using OOP concepts. And then later we'll kind of you'll see how it's a lot more powerful and how we can scale it quite nicely. Hopefully that makes sense. Right. So how do we start? Now notice I actually have a little file here called RPG, and I've got no code in it. Now my recommendation is before you even write a single line of OOP as well, you have to figure out one big thing is what are my classes? What are my classes? Right? And how do you do that? I would say you can use a range of tools. Let me give you one of my favorites. So one of the favorite tools I use as well is something called a UML diagram and online. So if you search for UML diagram, so I forgot what UML stands for. It's like Unified Something Module Language probably. You can Google what UML stands for. Now, I go for draw.io because it's the one I use, but there's a lot more out there. So if I take you to draw.io, so you come across something like this. So let me see if so this draw.io, so here is what we have. There's to the left of this, of course, is a bunch of stuff. If you guys remember entity relationships, so most of you will kind of remember what a table is, primary key and foreign key. So tables can be built like this. The one we're interested in is this UML. The UML will have something along the line of class. Here is class names. I can use that. So if I zoom here. So what I'm going to do is I'm going to create my entire logic, sorry, my design, my diagram for my RPG. Again, I want to build an RPG where Aragorn and Gandalf fight against some orcs, right, if you will, a text-based one. So I need to start here. So what I need to start is think, what am I creating? Now, remember, if I draw your attention back to our procedure, we're creating characters. So we're creating characters, if you will, or people, or something that represents this two-legged or more-legged creature moving. You could actually create a class called creature if you like. The name is arbitrary. It's how you use it and how you kind of mesh it with other things. That's important. So I'm basically going to follow that. I'm going to say character. All right. I'm going to say character. I'm going to name it character. Character. Now the thing I need to think is, what does my character have? Like as an existing thing, what are some of the properties? What are the attributes? Again, we've kind of covered attributes in object-oriented programming. This is the what is it? Is it? So I'm going to say this thing definitely has a name. So what else does it have? If we think, what else do we have? We can probably say strength. Strength is another good one as well. So health points, strength. What else does it have? It could have defense. Again, this is completely arbitrary. By the way, when you start out, don't stress too much about these details. You can expand these, and we can add more attributes as we need to go through. So basically, start small. Now, what else? So action-wise, so these are the methods. So what is it? What can this character do, action-wise? This character, for the time being, can attack. Probably can. As we expand this game, it can also speak or interact with objects. For now, we're just going to keep it simple. Attack. So far, so good. So I have created a character here. In my RPG, that's perfectly fine. Right. Now, what do I want to do now? I have a character here. So this character will then, I can create a hero from it. I can create something else from it. And this is where I'll start. I'll start for here. But at the same time, also, I'm thinking ahead. I would really like some objects as well. Some other non-character entities. So I'm going to, for that account, I'm also going to copy this, put it here. I'm going to say, you know what? Item. I like items. So what does an item do? I'm going to say an item for them definitely needs to have a name and definitely needs to have arbitrary. I'm thinking maybe an effect. Items have an effect. Item could be a sword, a potion, a shield, I don't know, a helmet. So for the time being, items, I'm going to give it an arbitrary, I don't know, use. So for example, it will have a method. Now, I may decide, this is the design phase, I may decide it's a great thing or bad thing, I may expand this or I might bin this. So that's perfectly fine. So I have these two, name. So now I'm also thinking down the line, okay, what else would this character will be? So I have, if I want to make Aragorn, Legolas, and Gandalf, I want these extra characters. So what are they? So I would probably think that, I definitely know Gandalf is a wizard. So he, as a character, he'll be a wizard. Right, he'll be a wizard. What else do I have? Aragorn. I'm gonna call Aragorn. Call me a ranger, but I might make him a generic fighter class for the time being, right? As a fighter class, and then Legolas is definitely an archer, so I'll have archer here as well. Now, here I have, again, carbon copies, if you will, of character. These are character, but at the same time, a little bit different as well. So wizard, for example, definitely needs that mana I talked about. So let's give it that mana. Also, I'm going to expand this a little bit. My wizard also needs to also cast spell. So apart from just normal attacking, could also cast spell along that line. So, and looking at my archers, what else? My archers definitely need arrows. So arrows in their quivers, and they need to shoot as well. Let's just say their normal attack, fine and all, but I would like them to shoot. So they have a range attack of some sort. So here, again, this is a design phase. When you sit down, you design this stuff. Don't worry if you haven't done your projects yet. As you're building, you can kind of then look at your code and then be like, okay, well, if we break this down to subparts, what would it be? So you guys see this is sort of my base of my design for my classes. So I was like, I have a main generic class for characters, any specialized characters, any specialized. So this would be my generic class for all characters. Whether it be an orc, a wizard, an NPC, some random person out there, I can just give them a character, give them a bunch of properties and methods, and I'm done. But if I need to specialize someone, I can have a fighter class, a wizard class, an archer class specialized. So far so good as well. Now here, of course, I'm looking at items as well. I might have a specialized item as well. So again, it takes 2 seconds to copy and paste this stuff. That's why doing this during design is much better than coding it, because you can kind of think about it. So without having to kind of work on too much code, and you can always just delete it if need be. So I'm gonna put potion. A potion. What would a potion have? A potion will definitely have a name. Effect. Maybe it has a restore amount. Again, I'm pitballing. I might make a health potion, so potion might have like subsections like health potion and mana potions, etc. So use is fine. So this is so far so good. Eventually we'll get to inheritance, but for now this is good enough for me. So I can start here. I have a design feature. So first thing I'm going to do is I'm going to come and create this fella. I'm going to start small. I'm going to create this. Once I create this and I have a few characters to test it with, normal characters, maybe they'll expand outwards. For that effect, I'm going to put this on this side so I can then zoom for you. Here we go. That is item. No, usually mongoose. Thank you. Here's character. So let's build this. So building. So object-oriented programming. So what do I need? I definitely need a class character. That I definitely need. So that's a class character. I'm going to call pass. Right. And that's my character. But at the same time, of course, don't forget the done domain. So if name city mongoose equals main, then run main function, create me a main function, define main. So what would I mark my main? Again, like very much like the procedural programming, I'm gonna call it hero for now, but I'll give it a proper name. I'm gonna say hero character. So now this character, what does it need? It needs name, hit points, strength, defense. It needs all this stuff. So I'm gonna have to pass these into it, right? And then I'll worry about attack later. So, but note, of course, if I pass like anything in here, for example, if I say hero, if I say my hero has 100 health points, has a strength of 20, and a defense of 15, for example. It's not going to work because my class here is empty. So let's go create a class. Now, hopefully, I'm hoping everybody kind of is okay with the basics of creating classes. But if not, we're going to kind of quickly go over it to say that the first thing you need in a class, of course, is the constructor. So now, what does the constructor do? Constructor basically takes all the goodies, these attributes we give it, and creates a state for your object. So here we're going to say name. The first one's name. The second one is health points. What is the other one? Is strength. Note that I can't write str because str is a reserved keyword. Shadow name it here, but just go ahead and just type the whole thing. Strength, that's fine. And of course defense. Likewise, if I say def, that's an error. That's just basically a keyword reserved, so I just say defense. So of course I'm then setting it up. So I'm saying self.name equals name. Self dot hit points equals hit points. Self dot strength and strength equals strength. And self dot defense defense, thank you so much, equals defense. So I've now created my hero class with this constructor. I've now created my hero class with this constructor because I moved this a little bit here on the way. Hopefully you guys see it. A bit more space. So, what? Now, just so I can test it as well, I'm going to say print hero. And as you know that this will not actually give you anything meaningful, but it will tell you that congratulations, you have created a character object. Here is in memory. So, but I was like, cool. Now I'm going to say, you know what, just to test out dot name, let me access your name. Are you called hero? Yes, you are. If I say how much hit points you have, hero, it says 100. That's perfectly fine. Right? So far, so good. Right? I have created this fella. Now note, of course, I also need a down here. Notice there's an attack method on this. And of course, in order to attach attack, I'm just saying define attack. I'm just going to say pass. I don't care. I don't want to implement it incrementally. We're going to go forward. So, lo and behold, I have a character here. So this way, I can then create as many characters as I want. Generic characters. Where's our orc friend? Orc. I'm going to call him orc. I just call him orc. Orc 1. He's an extra. Other places. Here's orc 1, and orcs have more. What is the 1740? Strengths, or if it's Lord of the Rings, they're probably like puny. So 15, let's give him 15. And defense, they're pretty bad to defend it. Here we go. So, and if I just print out my friend orc 1 dot hit points, just so I know they have different hit points, there it is. So that's my hero character's hit point, and that's my orc character's hit point. So far, so good. Hopefully that makes sense. As well, I apologize. I would normally say any questions and clarify it, but given this is a recording done at night, if you have any questions, DM me directly with the timestamp, and I will hopefully answer it for you. So that makes sense, hopefully. Right. So let's deal with this attack now. So far, we've created these fellas, but they're not doing anything. So I don't see anything happening. I have 2 objects in memory, but if what I want to say is, if you guys remember, I'm going to do this attack thing. I want to say, hey, attack hero 2. So attack from 2. So, and I want to use this. There's several ways to implement this. A very nice implementation, of course, is me just saying, hero, go ahead and attack a particular target, like orc 1. So I tell one object, they can go and attack another object. So the beauty of this is I can put in the method. I can attach a method to said hero, which hero, by the way, is an instance of character. So I can put an attack method on character that processes anything given to it. That, of course, is of the same type. Let's look at this. So note, of course, when I say orc as well, there's a little squiggly line here. This basically tells me that here I'm declaring an argument, but I'm not giving it attack. So here I'm going to say target. So, and just so I'm going to say print attack this person or character. So target, just so I know it works. So it says attack this person. Okay, this is perfectly fine. We want to have a character. This here object represents the orc 1. So it represents this orc object in memory. Now, later on we'll get this to look better, but we're fine for now. So how will we do this? It's pretty much the same logic as we had previously. I wanted to calculate some sort of damage. So I want to calculate some sort of damage. How would I do that? I say damage equals, and I have self dot strength. What is this self dot strength? When I say self, I've kind of explained this a bunch of times before, but hopefully this self is transparent for people. This self here returns to where this object is being called. So if I say hero, this is the self. So self here, dot attack, self is this hero. The entirety of the hero object going in. So when I say self dot strength, I'm saying hero object, this guy, what is your strength? This. So self dot strength means grab the strength of the person that is currently invoking this method. Then I have, of course, orc here, target. I can then tell it to calculate a damage and then take it off the health point of the target. So if I write something along the line, again this is oversimplified, but you can kind of make this more elaborate as you want. If I say target dot hit points minus equal that damage, it's exactly like the same thing we did with the functional programming, but this one it's a lot more just elegant and more contained and more scoped. This here says calculate the damage from self.strength, means the person that is attacking, what is your strength, which is the 20. Then of course go find the target's health pool. This is the target's health pool, the orc's health pool, and then take off that damage from it. So basically it's 140 subtract 20, which because is 120 remaining. So that is that logic here. So from here on, of course, I then want to then put in some print statements. So I print, like, say something along the line of self.name. So I want to say hero, orc, whatever that name is, okay, attacks. And then I said attacks who, target.name, right? Something along that was it, dealing this much damage. So dealing DMG damage. So if I run this now, hopefully we will get something meaningful back. So it's a hero attacks orc dealing 20 damage. So, and if we now print after that, if we say print orc1 dot health pool, we should hopefully see it be 120 from 140. So we have managed to kind of create an attack method for our class. That so this is the beauty of it, every instance of this character, whether it be this hero, orc, or any other character you create, will have access to this attack method. And it's quite nice. So we can also say, at this point, we can say orc1 dot attack hero. And if I then print out our hero dot hit points, you can see the hero attacks the orc for 20 damage, the orc is 20, the orc then attacks the hero for 15 damage, our hero now has dropped to 85 from 100. So you can have some sort of game where of course, on a turn basis, these two will attack each other, maybe add a random, you can add a random feature or functionality in here to make the, gives it some bit of a random edge, etc, etc. I'm gonna basically put down the bulk concept down. You can later optimize and tailor it and expand it as you see fit. So hopefully that makes sense. So what we've done is we've implemented on the right here. We've implemented. Oh, sorry about that. Excuse me. We have implemented, my friends, this here character. We've made sure that each instance of this here attributes go in it, and there is an actual working attack feature in it. So this is basically we have done equivalent to this here procedural programming. So this is procedural programming. I'm going to split this right, split right. This is object-oriented programming on the right. Now, a couple of points here, very important points as well. Note, if I minimize this class, note that the attack and the properties are all in one bundle. Notice that the beauty of classes is now my logic here for both a character and its attributes, as well as the attack, are bundled nicely and scoped nicely into a character. Well, as of course in procedural programming, this is its own thing separate, this is its own set, so the data is very separate, and this could be problematic because you want to have some sort of relationship between these two, but of course you don't want them separate like this. This is where classes are very beautiful, so quite nice to be used. As we expand character, the more the character does, the more functions we have to add on procedural side, and the more methods we can add on the OOP side. The OOP side will have it nice and tailored. The states will be maintained. So this state will be maintained quite nicely. The attacks, of course, can access said state, and it's a very elegant way to do it. This is an example of encapsulation. So we've encapsulated the data in its own contained environment. We can then create said characters and then use said internal methods whenever we need to without having to worry about anything else beyond that. So this is one of the superiorities of OOP compared to normal procedural programming. That's one. So that's one. Two, we can now expand this quite nicely. If I need to create a wizard, or if I need to create a fighter, or if I need to create anything else, I can expand this. character without having to rewrite or update or go ahead and tear up my entire structure here. Now, to that effect, we're going to retire procedural programming for now. And then we're going to talk about a second very important part of object-oriented programming, and that is inheritance. So what do I mean by inheritance? Let me take you back to these UML diagram bars. So let's start with character. I have a character here, right? This character, perfectly fine. Right. Now, of course, I want to then have a fighter. I want to have a wizard. I want to have an archer. But note that there's a lot of shared similarities here. I have name, HP, strength, defense, name, HP, strength, defense, name, HP, strength, defense, etc., etc., etc. So these are, at the end of the day, each of these are actual people, actual characters, really. So when it comes to object-oriented programming, when you have something like this, where there's a lot of repeating functionality, a lot of repeating attributes, you want to use inheritance. So what I'm going to do is I'm going to take this guy a little bit higher, and I'm going to do this. I'm going to click on this. I'm going to draw arrow from 2. From 2. So that's that. From 2. From and 2. Please cooperate. Computer, cooperate. I beg of you. You know what? Fine. Good enough. Item equals stand over there for this. So. What this means, of course, as I'm sure you already know from Anuja's class, this means that Archer now is a subchild. So is a child of character. Wizard is a child of character. Fighter is a child of character. To that effect, of course, what also inheritance specifies is that you now don't need to repeat all of these continuously everywhere. Basically, any child of a parent class will automatically inherit all the attributes of the parent class. So what I can do is I can clean up, basically. I can go in here, zoom, zoom, zoom. I say, look, fighters. It doesn't need any of this. It'll take it all from the parent. Actually, you know what? Attack. I'll leave attack here, but so far it'll take it from the parent as well. But, oops, I did not mean to do that. I'm just maybe, for the fighter, I maybe put extra strength or something like extra combat skill. Something along that line. Again, this is arbitrary. I'm just making this up. But you can do as you will with it. With the wizard, I definitely want, what do I want? Definitely, I don't need these. These are being processed by the parent. For the wizard, I'm going to say definitely want mana. Or actually, what I would like also is maybe a spell book. Definitely want some spell book. Cast spell is perfectly fine. For the archer does not need any of this stuff. Only needs arrows. Maybe I give him speed. Maybe I want speed. Maybe I'll think about it. But definitely arrows as well. Attack, shoot, football. So now the parent basically has all of these. That's nice. I like this. That's inheritance. So now I can create all of these very quickly using inheritance. Let's go with the fighter. Let's give you an example of a fighter. Now I'm going to put this on the side here. And let's do a fighter example. So I am going to create a fighter class inheriting from the main character class. And then we're going to kind of work on that. So I'm going to do things we don't need. For the time being, we don't need any of this stuff, as we'll have the orc character there for the time being. I'm going to say, okay, class fighter. A class fighter. Now, how do I do the inheritance thing? How do I tell it that you need to go and grab all the stuff from this here character class, right? And the way you do it is basically you open a parenthesis and say, hey buddy, you are now a child of character, meaning you inherit all the goodies that are coming from character. So I'm going to pass it here. So from here I can actually bring in Aragorn, please pronounce like that. So he is going to be a fighter. He is going to be Aragorn. And voila. Now, so far so good, but there's a wee bit of a problem here. Where is this stuff going? So Aragorn here needs to be created as a fighter. And if I run this, and I basically print Aragorn, maybe ask for his name. I don't actually, surprisingly, it automatically is going up the food chain. I didn't mean for it to go. But what we need to do, and what is nice to do, is actually called create its own constructor. So the way we do, of course, is we basically say init, and we can basically, there's a couple of things you can do here. you can explicitly specify a constructor method for it. So for fighter, now we have here again name, what's the health points, strength, and defense. And of course you can then set these up towards the parent, right? You can explicitly say init, call the parent, send all of these up towards the parent. So that's what you can do actually. So here, you can explicitly basically say, hey, my fighter, name, head points, strength, defense, and these will automatically get passed upwards here through the super init method going up. However, be mindful that given that this is one-to-one inheriting from above, you can actually just not, if you don't do any of this, this will still work. So if I say pass here as well, funny enough, you can still say Aragon dot attack our little orc friend, and of course if you do a print of the orc one's health, you see that everything is still working. The reason this is working, of course, is the magic and the beauty of inheritance. So even though Aragon here is a fighter, a unique subclass here, specific fighter, and everything is being passed, and there's nothing in it. This class has nothing in it. It is, however, a child of character. So when all these goodies come in here, if there's nothing in here, they'll automatically be passed up the food chain to their parents. So, and the parent, of course, says, I have it covered. Likewise as well, if you call a method that doesn't exist, so note I'm saying Aragon of type of fighter, he's my fighter, attack. There is no attack method here. There is none. So if Python cannot find the set attack method or that method in that class, it will then push it upwards and check its parent. And of course, if it comes up here, the parent does have the attack method and this is used. So if it's not here, it goes up and it's used up here. So Argo here is our fighter. Now, this is fine, of course, but we kind of want to give our fighter a bit more oomph, right? We want to give our fighter a bit more oomph. If I look at a design, I was thinking my fighter would have some like extra combat skill or something, or maybe have a bit more oomph behind his hits, because I want to make this class a little bit more unique. Now, to that effect, again, there's a bunch of things you can do. Right. I thought about it for a moment. The most elegant way you can solve this to give the fighter a bit more oomph is to come and do this. Note that a standard character, let me just explain this. A standard character, of course, whenever it wants to attack something, it then uses this method, right? This method here is right here. When Aragon tries to attack the orc, because there's no attack feature here, method here, it goes up and the parent class picks it up. You can use another very useful thing of object-oriented programming, and that is polymorphism. You can override a child class can override any parent method. What do I mean? Let's take a look at this example. Currently, if I do an attack, if I run the attack on this orc at a health of 140, I get 120 back. That's meaningful because Aragon here has 20 strength, hits the orc for minus 20, and 120 is out. That's where you see it, right? And of course, this is all calculated. All of this is calculated in this attack in the parents in the character class. What happens here, if inside this class I say, look, I want to declare my own unique attack for this fighter. And I'm for now, for laws, I'm going to say print here, fighters don't fight. And if I just say that, and now if I run this, note here that when I attack this orc on line 25, the attack goes through and it gets picked up by this attack in the fighter class. And of course this fighter class here says, well, fighters don't fight, so voila, you get this. And of course my orc is still standing there at 140 HP. This is referred to as method overriding. So you are basically overriding the parent's method. So basically we're going to use this feature to give my fighter a lot more oomph. So again, there's several ways to do this. I'm going to, first of all, I'm just going to copy this. I'm going to copy this. I'm going to put it down here. So now, you can have your dedicated fighter have its own arbiter attribute for extra strength. But for the sake of time, I'm just going to go ahead. I might add this, I might add it later, but I'm going to keep it simple. I'm going to say my damage calculation. I'm going to say my fighter here has a extra fighter combat skill add-on, silly name, of 8. So fighter, if I could spell. And I'm going to say, when it comes to damage calculation, how am I going to do this? I'm going to say the damage calculated is going to be self-defense strength plus the extra combat skill. And I noticed as well, because we do have a defense attribute for each character, we could probably put that into play as well. So when we're calculating the damage, how about we wrap this up together, and then we could take off maybe the defense. So target.defense. I think it's the targets.defense off of this. That probably makes more sense. Defense. So this way it gives it more. So this other features can be used. Actually, we can do the same thing here as well. So strength minus target.defense. Alright, cool. So now this defense comes into hand. So that the strength gets subtracted by defense, of course. And voila. We might have to do some extra math as well, make sure it doesn't go below 0, or if it's absolute and doesn't go into the minus, negative, etc. But we're not going to worry about that at the moment. So with this, of course, my fighter should have more oomph. So when my fighter attacks an orc, instead of 120, actually we cut into defense. Maybe he hits really hard, like an extra 18, because it's a fighter, he knows what he's doing. And then hits our orc in the, as well for extra damage. So now the orc is at 112 hit point. So this is an example of inheritance and polymorphism, more specifically of method overriding. So now let's come about polymorphism. Polymorphism basically means it can be two things. So note that when we have a fighter, our fighter is also a character. So Aragon here is both a fighter and a character. So he's polymorphic in nature. It means many shapes. So that's basically what polymorphism is. Inheritance automatically brings polymorphism into the fray. I might do a completely separate video on dedicated polymorphism later. But for timing, let's just go through this and you'll probably pick up most of it anyways. So hopefully. I hope any questions so far, but if not, DM me for questions. If not, we'll move on. Right, so let's go look at a different thing now. Related. I'm just go ahead and ignore all this attack stuff. I'm going to go ahead and print just my characters. I'm going to print Aragon here. I'm also going to print the orc as well. Orc 1. And if I run this, I get this. I'm kind of tired of this. I don't want to be seeing this anymore. I want something elegant. I want, if I print my character, I want something elegant point. This object in memory is no longer a good thing. Now, how do we deal with this in object-oriented programming, or in general in OOP? There is a particular Dunder method. There is a very, very clever Dunder method, and I'll put it here for you. There is a Dunder double score str. And note, I'm going to bring Dunder str here. I'm just going to say return meaningful things about this class. Again, if I run this, instead of getting that object in memory, I get this now, meaningful things about that class. Right, again, if I take it offline, computer, cooperate, I get objects in memory fighter class. So you see it's Dunder str. What it does, also equivalent to this, there's also another one, I think Dunder reps as well. Both of these pretty much do the same thing, with very tiny differences, which you do not need to worry about. So these special Dunder methods, now these are methods on the class, you put them on a class. Here, notice this character class, I put these. You can pick either one. I like Dunder string, but Dunder rep is also legit as well. What these do is they give a text-based representation of this object in memory. So instead of having it printed here, object in memory, which is meaningless, you can tell it to represent something meaningful, like a meaningful output. So let me give you guys something meaningful that I'll grab for my notes. I'll grab for my notes for the sake of time and copy it in here. Let's take a look at this. And if I run this now, you see this. I said, hey, Dunder String, from now on, if anyone wants to know exactly what this class is and names it directly, just say the name self something HP. I think there's one extra F string in here that does not need to be, but it doesn't matter. So he says Aragon, HP of 100, strength of 20, defense of 15. So basically it gives me a detailed rundown of my character. So this is a Dunder String. Hopefully that makes sense. You can add a Dunder String to any object or any class to kind of represent that class. Right. What I'm going to do is I'm going to go back to the board. So this is a very useful thing. This is a very nice thing. I like this a lot. But also I want to enforce it across the board. So let's go back to the diagram. What I want to do is I want to make sure that everyone has a Dunder String. A Dunder String so that they all print out nice elegant things so I don't have to worry about pointing at things. So how do I then enforce? How do I tell everything here that it must implement a Dunder method? So welcome abstraction. So let's take a look at abstraction. So what I'm going to do is I'm going to, for now, I'm going to copy this and then bring it up here. So I don't need, I'm going to leave name in there. I'm going to also say here, method, I want a Dunder str, and I'm also going to make it mandatory. So here's the deal. I'm also looking at I'm looking at my entire structure as well. So I'm back at the drawing board looking at my structure. Say characters, yes, they're inheritance. Yes, I've cleaned it up. But also at the same time, I've got name, I've got name, I've got name. So now these of course inherit from name, but I'm still having names between items and characters. So instead of having this name be here and here, how about I send it all the way up to its parent class, to the parent, to the highest order here. So I'm also going to call this, I'm going to give it a name that makes sense, like entity. Again, this is an arbitrary naming convention. You might have a better name for this, so feel free to name whatever you want. Now I can basically say this class inherits from this class, an item inherits from this fella, entity, and go ahead and potion can inherit from item. So potion doesn't need a name anymore. This is out. This gets passed via the parent. Name item itself, computer please cooperate, doesn't also need this name. That gets passed by the parent. Actually, character here no longer needs this name either. That gets passed by the parent. So now there's a couple of things. Now I can leave this. I can leave this to be just a normal class. I can leave this just to be a normal class. But I kind of want to make this more robust. I want to basically specify that I don't want anyone to actually create. I don't want someone to be like, okay, entity equals entity constructor stuff. I don't want this to happen. I want to make this very uniquely abstract. So enter the abstract base class in Python. So Python has an abstract base class where you can specify the entity, and I will do so by printing a parenthesis here if computer permits me. I'm going to say abstract base class. This specifies to Python that nobody should create this on its own. It's only meant to be inherited from. It's only meant to be inherited from. I'm going to quickly create this. This is an example of abstraction. In your projects, I would like to see abstractions. There are marks for this, by the way, so just heads up. So let's go put this on the side here and take a look at how to kind of do abstraction. So it's going to be between, once we do entity and character, everything else tends to fall in line. So I'm going to put this on the left side here, maybe a bit more space here. So here I go above character. I'm going to say, look, I want a class called entity. This class entity is going to be an abstract base class. And the way you do that, you say abstract base class. You go ahead, let me say pass for now. You then import abstract base class. So from ABC, the module, so this is underscore ABC, the module inherit the abstract base class. You then, now entity inherits from this. Now basically at this point nobody can create entity on its own. Everybody must inherit from entity. So what would entity, so you can't specify nothing here, but I'm going to go ahead out of habit. I'm going to say define init. I expect to see a name here. And anyone that names, you have to get self.name equals name. I'm also going to say this. Oh, by the way, before I do the methods as well, I know there's a method here we want to implement, but I also want to fix this name thing going from character. So character here no longer has its own name. Character has to push it upwards. So the way you push it upwards towards the parent is you get rid of this. You just basically say, hey, I want to call the super. I want init, and I want to pass name. Now, and of course, you make sure that you say whose super it is. Entity. So, now, hopefully fighter will be fine as well because it goes up the food chain. Just so I can't over-explain this to you, to people. So, basically, I've come to character. It's a character. From now on, I want you to inherit from entity. This is what we're doing here. We're saying character, inherit from entity. Entity abstract base class, it has name. I don't want you to have your own name anymore. I want you to pick up name whenever you need to, but please push it up towards the parent. The parent is now in charge of this. So entity is now in charge of kind of scoping this. So that's basically the super here. Super says go talk to your parent. Here's this. Here it is. This parent. And then pass in name upwards. So name goes past here, gets past here, and is then assigned here. So that's fine. Now, I also want to say I want this dunder str to be mandatory. The way you specify mandatory methods is you come into any class. This doesn't necessarily be a base class. It could be any abstract base class. You can say, hey, define underscore str pass. It needs to be a pass. And you put this very nice decorator above it. Actually, I'll import it first. You import the abstract base class method. So you say abstract base class method. So now this for this course, predominantly for this course, this is the only two you really need when it comes to abstraction. So the abstract base class here created here has this special decorator. I've used it. This decorator hack that it is. If you ever put it on top of something, it basically says that any child must have this. It must enforce this abstract base class string. Now notice we have it here. We already have it. But should I, for example, if I delete and remove this, if I remove this, right, and I kind of look, notice there's a little squiggly line down here. If I hover over it, it says class must implement all abstract methods. So basically character is angry as well. And I think fighter is also angry as well. It must implement all abstract methods. So, and if I just go ahead and say, okay, what are you talking about? It says implement abstract methods. It says here it is. You must implement this str of from entity, coming from entity. And if I say okay, it will be put here and it expects me to kind of do something with it. Well, the joke's on it. We've already done something with it down here. So by adding this str up here, we have ensured that all children downwards have already implemented this mandatory. So the mandatory here, if the parent implements it, all the children will have automatic access to this. And if the children want to have their own unique way of expressing this, then they can override it should they want to. So hopefully this makes sense. So this covers sort of the concept of abstraction. So note that I brought abstraction in for two main reasons here. One, its name here is being used for pretty much everything on the character side as well as everything on the item side. Again, item and characters don't have a lot of overlap. They do have a overlap. That overlap can be abstracted up. So, and this is quite nice because later if I want to expand on this entity, I can also force other more important things down here, should I want to. If not, I can undo. So this abstraction is a very sort of a, there's better ways to do this, but this is the most easily understandable example I could come up with. So hopefully it makes sense. Now, with that effect, let's go and take a look at character. So here we have character fighter. Let's go make ourselves, I don't know, a archer of some sort. Right, so archer. Let's look at this here. So what is the archer doing? The archer is down here. So I can use this blueprint to kind of create an archer, and it's pretty much straightforward at this point. So I have, here's a fighter. Right underneath it, I can create an archer class right here. I say class archer. Again, archer will inherit from character. What would this character need? So let me see. Let's go and add in, because I want to give more stuff to this, I'm going to create an init method for it. I'm just literally to be very explicit about this. I'm going to say init, I want to pass it all the things this archer needs. I got name, what does it need? Name, hit points, strength, defense, but also my archer needs arrows as well. Notice there's arrows. And of course, because character pretty much eats all this stuff up anyways, so all I need to do is say super, call the super, call the init on the super, and pass it name, hit points, strength, defense, all the way up. But for the archer, I want to keep the arrows scoped here, because again, character doesn't deal with arrows. Character has no arrows. There's no arrows here, and his parent only has name. So arrows are a unique attribute for archer. So here I have no problem. I take and I say arrows, self.arrows. This could be total arrows, by the way, like, or number of arrows, doesn't really matter. I'm going to say arrows equals arrows. Now, so here's so far as well. Now I can note for attack. Attacks, now I don't want to particularly use just this basic attack here. I want to kind of get archer to do its own thing. I want to override the attack. So what an archer should do is basically shoot. So shoot something, arrow. I want an archer to shoot arrow, again, maybe at a target. So I'm going to print here, just for test purposes, shooting an arrow. And now I don't want to then expose this method. So if I have, let's bring Legolas in here as well. Legolas, I think it's pronounced, is an archer. His name is Legolas. I go hit points, probably 90, 80, strength of 10, defense of actually quite fancy fella, 20, and number of arrows. I'm gonna say number of arrows is carrying 30 arrows. As you can see, it's kind enough to see 30 arrows here. So 30 arrows, cool. That's Legolas. So I want to have basically Legolas here, the attack. Our poor orc friend here is taking a beating, bless him. And also I want to print our orc friend at the end here as well to see what he's doing. Now notice if I do that and run it, of course, the attack kind of goes Legolas attack orc dealing 0 damage. Mostly because this attack here is strength of 10. The orc has a defense of 15. It's not coming through. I want to instead override the attack in the character class. I want to hijack the attack method of the parent and make it my own. So here instead I'm going to say, what can I say? I'm going to say attack. So define attack the same. It has to be the exact same name. Because when I put it down, now I've written, I've said something along, but for now I'll just say just shoot. So self dot shoot arrow at the target. So pass the target through. There's just a couple of things happening here. Let me walk you guys through it. I've created archer class, is inheriting from character. Remember, character also has, if I can bring it here, character has the attack and defense on all the goodies. Now, I don't want to use the default attack here for the character. I want to override it. I want to take this and make it unique for this archer class, overriding its parent method. And the way I do this, very much like all override, I just rename. I just name the same thing that the parent has. I basically say attack, but now this is my attack for archer. Here, I then say self.shoot arrows. Now, self.shoot arrow refers to this. Self means target the class itself, find the method, shoot arrow, which is this fella. So this shoot arrow here, from now on, I can do stuff with it. So it depends. From here on, it's just basic Python logic. So what kind of logic do you want to kind of put in? So for the shoot arrow, for example, I would say, I don't know, calculate the damage, right? Calculate damage equals self.strength, add strength, minus target's defense, right? However, because I'm going to put in arrow damage, arrow precision damage. I'm going to say 3. I'm going to put 2. So in my damage calculation, I'm going to be like, it's pretty nasty taking an arrow to the knee. So I can say multiply by arrow precision damage. No, I can kind of calculate this way. Then I can say target dot HP minus equal damage. And what else can I say? I can say f string, so self dot name, right? Self dot name attacks target dot name. Again, these are all straightforward. With arrow causing dealing and target actually just damage. Actually, what am I? If I just run this as well, make sure that's actually working. So Legolas attacks Orc with arrow, dealing 10 damage. So, right. So I kind of want to add in. I want to add in the fact that he is an archer. So far, I'm not putting the classes in. So we're going to do something, and this is not crazy syntax. I'll just expand this for you guys. So in the F string, I'm going to say parentheses, but I want to specify what kind of class this is. I can say self.class, dot the class, dot the name. So nobody panic here. Let me just quickly run this for you. And you can see it's actually very easy. So note what I'm getting here. I say Legolas archer attacks orc. So when I say self.dunder class, I basically say, hey, tell me about your class. This dunder class is this. And I say, hey, what is your name? It then gives you the name. So dunder class, dunder name. So these dunders are unique to Python, and they're basically reserved words and variables for set class. So you can do a lot with them, and there are a lot of them. But for now, this way I can have Legolas the archer attacks Yadi. So that tag is quite pitiful, actually. Let's just bump him to like 3. 20 damage. That's more like it. That's more like it. So this again is an example this is an example of some logic as well with some extra classy stuff. But notice that this is my overriding. So I need to kind of check to see if I have arrows. I want to check here to see if Legolas actually has any arrows. So how would I do that? This is again Python logic. I would say if self.arrows. If there are arrows greater than 0, means if Legolas actually has some arrows here, right? I'm going to say, Legolas, go ahead and shoot away, man. Go nuts. Go to town. But also, please keep a track of the amount of arrows and take one off. For each arrow shot, take one off. And you can also print, for example, I don't know, what do we write? Total self.arrows remaining. Arrows remaining. So if that's the case, when Legolas shoots, it says yeah. So Legolas shot 1 arrow at the orc, caused 20 damage, and of course 29 arrows still remaining. That's pretty nice. So here, if I then add remove arrows, it gets calculated here. But also I want to check the fact that if he runs out of arrows, else if he's out of arrows, you probably have to draw a sword. But I don't want to put that logic in. That takes extra time. I'm gonna say something easy like print. For the sake of time, print, what am I saying? I would say self.name is out of arrows. Can't shoot. So now, just to test that, I'm going to get Legolas to shoot like 3 times. He's still got 27, but if I take, for example, if I only give him like 2 arrows, if I give him like 2 arrows, say 2 arrows, thank you. Yeah. So he shoots 2 arrows. He shoots 1 remaining, and Legolas is out of arrows. Now you will probably have to go and kind of stress test these and kind of work on them, expand their logic, but that's good enough. So let's give him back his 30 arrows now. So that works. So you guys can see now that my archer class. Please stand by. I think somebody is right. Sorry about that. Now back, what was I? You kind of see, there's the beauty of object-oriented program. If you guys remember, we are kind of expanding really nicely here. So I put an archer class as well. I inherit from character. I can pretty much pass everything that is already sorted back up the food chain. So that deals with it. If I then want to expand this character, I have all the ability to give him all his method. So you can have many different like methods here that do different things here. All they have their unique logic. You can hijack and override parent methods all you want. So that's basically it. Now we're going to quickly, just so that we have the entire team together, most of the team together, I'm going to go ahead and create the wizard as well. So we can't just not create Gandalf. So let's create Gandalf. So class wizard. So by the way, if you want to pause right now and kind of create Gandalf yourself, you want to kind of think, when you're creating Gandalf, you want to think, for my wizard, it kind of he needs mana, he needs a spell book. The spell book here kind of needs to be an object, a dictionary if you will, or a list. of list or matrix. It has cast spell, very much like Legolas's shoot. It kind of needs to override attack. So if you want to kind of give that a whack yourself and then come and look at mine, feel free to do so. Now you can come on pause this video whenever you want. So I'm gonna say again, character. We're gonna pick up the character. That's perfectly fine. So again, Gandalf. I'm gonna kind of borrow from Legolas here. I'm gonna give him all of this. I'm gonna pass him. Yank. So here we go, Gandalf. Here's my wizard. So my wizard doesn't need arrows. So arrows out. Instead, he needs mana. So it says mana equals mana. But also he'll have his own spell book. Self-taught spell book. And for the sake of time, let me just give you my notes. This is a spell book I put together. So feel free to kind of put your own spell book in here. So I do not need to be a nested object. What is wrong with you? Are you upset? There we go. So that's a spell book. So now there's more than one way to write this stuff. I just do objects are very dictionaries are like very robust. Dictionaries for the win. Now you can write a matrix if you want for this, but dictionaries is generally better. So for my spell book, of course, I've decided on Fireball, and for Fireball they'll have a mana cost of 15 and a total damage of 30. I put Ice Shards and Lightning Bolt as well. And I do realize that Gandalf never used this in the movies, but we're gonna go with fantasy realm. I know. But so what are we talking about here? So we have this, and what we need. I also need to do two more things. I need to have a override. So I need to override attack. I need to override attack here somehow. Maybe a target. Maybe more. I'm gonna leave it here. But also at the same time, I also want him to have his own cast spell as well, where he kind of targets something. Maybe our poor orc friend targets, and then maybe he's actually we can tell him which spell to cast. So target and spell. So here's what I was thinking. So for the attack for Gandalf, we'll keep it simple. We just say self-taught cast spell. And cast spell, what do we tell it to cast? So cast target and and spell. So here I'm going to do something else. I'm going to show you guys how you can put a default on as well. I'm going to say by default, if nothing is given, automatically cast Fireball. So let me just also make sure that works, and then I'll explain it to you guys. Print casting target spell. Now if I ignore that, so let's put Legolas out of here. Gandalf. So Gandalf is a wizard. He's probably 16. That man is a lot stronger than he looks, so I'm giving him 15. He has like a ridiculous amount of defense. Also arrows. He doesn't have any arrows, but what he does have is mana. And we'll give him 15 mana. I just noticed that he's an archer. He does not need to be an archer. He is a wizard. Wizard Harry. So that's our Gandalf friend. Just so I know, I'm just going to quickly call Gandalf.attack. And we're going to attack our poor orc friend here. And I'm going to run this to see what it gives me. So it does say casting. I'm targeting orc 1 and here as his stats. And I'm casting Fireball. So if you guys look, this is basically it. I'm saying casting. This is casting. Here, target is this orc friend of ours. And of course, the spell is Fireball. Now notice I haven't specified spell here. Now if I say spell is lightning, that's lightning here. So you can, so basically this spell, let me just quickly go over the concept of overriding here. Default valuing. Here I'm saying in the attack, I'm saying there's an automatic self that always goes in. That's perfectly fine. There's target. Notice here Gandalf is doing his attack. This is target. This is target here. But I also have this spell here. But this spell has like an automatic default assignment of Fireball. Which means I actually don't need to pass anything here. The computer will not expect me to pass anything. So it basically says spell here is an option if you want to send it, but it's already there. So if you put nothing, Fireball will go through. But if you want to, I don't know, then put another comma, put in something else, notice the spell concept pops up and you can say, oh no, Ice Shards. And lo and behold, if I just get this out to run this, ice shards going through. So that is our spell. So I'm going to keep it the default fireball for now. Now, how you decide to write cast spell here is up to you. I'm just give you my notes so you guys can see what I've written, and I'll walk you through it. So here are my notes. Please stand by. Now, it looks a lot, but actually it's a lot simpler than first seen. So here's what's happening. I say if the spell is in the spell book. Note that it checks to see if the spell is in the spell book. So what is my spell book? Here. I have a spell book of 3 things. Fireball, Ice Shard, and Lightning. Now if somebody just invokes Bob, there is no Bob in this. So Bob won't happen. So down here, if Gandalf calls on Bob, nothing's going to happen. Because there's no spell Bob. Does not know the spell Bob. So hopefully that makes sense. So this is what this here check is for. So there's a check here to see if the spell is in it. So here is the check associated with if there is no spell in the spell book with that name, we get the spell if Gandalf does not know the spell, in this case Bob. So that spell. Now it goes and does a spell cost and a spell damage. It's very simple. It checks the spell book. Let me just give me a second, people. Let me split this to the right and then make this properly. Split it right. Here it is. So this is our spell book, right? So this is our spell book right here. It says go to spell book, check spells. This is a spell, right? Spell books. And which case, if it comes fireball, if it's fireball here, this is fireball picks up. Pick up the cost. Basically, pick up this guy. If it's fireball, it'll pick this guy. So spell cost will be fireball will be 15. Spell damage, check again, same thing. Pick up damage. Be damage be 30. So this part, of course, pulls out the bits required for the spell. Now, next, check to see if Gandalf actually has any mana left. So if he has mana, if he's not too tired, if his mana is also greater than the cost of the spell. So if his mana is less than 15, he can't cast Fireball. If it's less than 20, he can cast Lightning. If it's not reduced, subtract the mana, and then go and do a spell damage. So take the HP of the poor orc, and then just basically take the damage off. So basically, if this is the part where it inflicts the damage, and from here on, it's just basically just giving you a message to say, Gandalf, the wizard, has enacted such spell on the poor fella. I just say it. So this line is this line here. It says, Gandalf the wizard, has casted Fireball. Here's a spell, dealing spell damage, dealing 30 damage to the damage. I didn't say the orc. This much mana remaining. So voila. Again, there's a little bit overriding here, but nothing too crazy. At this point, you guys should be very comfortable creating your own subclass. So you can create a barbarian, a bard, a druid, anything else, and then thinking how. And you also, my advice, always come to the design board first. Design things on the board first before you code them. So that's an easier way to kind of get your head around things, and then it forces you to think about the concepts as well. Now, for this point, at this point, we're kind of done, really. You guys understand the general concepts. What we have not done, or we have not focused on, is just privatization of these roles. So we haven't set any getters or setters here for the sake of time. So in an ideal world, you also have getters and setters for all of these. But because inheritance, you only set getters and setters in the parent once, and you're done. All other implementations can use the same getters and setters in the parent, and then no longer do you have to then rewrite setters and getters for any of the child components. So hopefully that makes sense. But we've definitely we talked about abstraction, polymorphism, all the other goodies. So my recommendation is try to make something like this yourself, or better yet, note that I have left the right side empty here. So we haven't really created any of the items. So you create an item, create a potion, maybe go to create a sword or a shield. You can also here add an inventory as an array. So each character can also have maybe a bag or an inventory that can have an instance of an item in it. So Gandalf can have like 2 potions. Aragorn can have his sword, and etc. 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 So think about how you would implement this. and feel free to kind of send me your solutions should you have them. Now, hopefully this crash course in object-oriented programming has been helpful. Well done all for making it this far. And if you have any questions, DM me or Anuj, and we will be more than happy to help you out. So have a lovely night, and see you guys soon.